do a lab work now. Now, what does the lab involve? Now, first of all, let's talk about this. A wave has the following characteristics. What are the characteristics of a wave? A wave has a wavelength. And I told you a wavelength is made up of a full crest and a full trough. And in the case of the wave that you saw, the length of a wave contains two full loops. Is that right? Yes. So a wave has a wavelength. A wave has a frequency. Frequency is the number of vibrations per second, or the number of waves produced per second. And a wave has a wave speed. Now, in this lab, we're going to study the relationship between the wave speed, wave frequency, and the wavelength. A relation between wavelength, frequency, and wave speed. All right, you should now tell me, what is that relationship? The relation between wavelength, frequency, and wave speed. The wave equation. What is that equation? Well, the equation is V equal to F lambda. Now, what we're going to do is we're going to generate waves on a string, just like the ones I showed you. I'm going to repeat that. We're going to generate those waves and measure the wavelength, and then measure the frequency, and use those two values to calculate the wave speed. So what are the measurements we are going to take? We are going to measure the wavelength, and we are going to use the frequency that we can measure from the machine. I will measure it and give it to you. All right? So we will measure the frequency, we will measure the wavelength, and then calculate the wave speed. That's what we're going to do. And now you must stop the video and get the worksheet. Now, print out the worksheet and bring it over and do the work with me. What I'm going to do is I'm going to help you fill the tables with the values of F and lambda, and then you will calculate the values of V and complete the worksheet and then email it to me. All right? Okay, let me set it up now. Well, I have set up the apparatus so that you can read the frequency. Can you read this value? That's actually 1.2. This string is now vibrating with a frequency of 1.2 hertz. Just one vibration a second. Can you see it happening? Yes. But is it resonating? No, there is no resonance, because the natural frequency is not equal to the imposed frequency. All right, what I'm going to do is increase the frequency so that we see the string vibrating in one segment. All right, we're going to get one segment. I'm going to increase the frequency and watch this. Okay. Well, what is my frequency? This time, my frequency is 11 hertz. 11 hertz. Okay, I'm sure you can read it. So, let's write down that frequency. The frequency is 11 hertz. Okay. And let's measure the wavelength. What is the wavelength of this wave? This now has just one crest. So if I measure the length of the string, I'm measuring the length of the string, and it is exactly 1 meter. I hope you understand that. This is exactly 1 meter. All right? So half the wavelength is 1 meter. What is therefore the wavelength? The wavelength will be 2 meters. Okay? The next one you need to write on your own. Alright, I got the frequency 11 hertz, the wavelength is 2 meter, therefore what is the wave speed? I'm going to leave it for you to do on your own. V equal to frequency multiplied by the wavelength. And I want you to write it with proper units. What is the unit of speed? It's meter per second. Alright? So here, the wave speed will be 11 times 2. That will be 22 meter per second. I'm not writing it down. You got to write it on your own. Now, what is the next part? I change the frequency so that I see the string vibrating in a second harmonic. Alright? I'm going to increase the frequency. What do you think the frequency should be for the string to vibrate in a second harmonic? Well, I'm going to increase the frequency to 22 Hertz. Now, watch this. The frequency is 22 Hertz. And now, you have the second harmonic. And what is the frequency? The frequency is 22 Hertz. I'm going to write that down. The frequency is 22 Hertz. Alright, what is the wavelength now? Can anybody tell me what is the wavelength? Now the string has a full wave. The string now has one full wave, a crest and a trough. So what all I need to do to obtain the wavelength is to measure the length of the string, which is 1 meter. So the wavelength now is 1 meter. So the wavelength is 1 meter. And now calculate the wave speed. Okay, next I'm going to go to the third harmonic. Now the third harmonic is when the string vibrates in how many loops? There will be 3 full loops. So I'm going to increase the frequency so that we have the third. Yeah, there we are. This is the third harmonic. The string is now vibrating in its third harmonic. You have a node, antinode, a node, antinode, a node, and so on. Now tell me, how do I measure the wavelength of this wave? Now remember, wavelength contains a full crest and a full trough. So this is a full wave. In other words, a full wave contains 2 full loops. So what all I need to do is measure the length up to here. Let's do that. From here to here. I've got that length as 70 centimeter. I must write it in meters. Now 70 centimeter is how many meter? Is 0.7. Alright, so the frequency is 33 Hertz and the wavelength is 0.7 meter, and I want you to calculate the wave speed. Calculate the wave speed. Now I'm going to increase the frequency so that the string vibrates in its fourth mode. Alright, let's increase the frequency to there we are. Now I need to adjust this because it's been sort of falling off. 45.6 Hertz. 45.6 Hertz. That is the frequency now. And what is the wavelength? Remember, wavelength is a full crest and a full trough. So I measure from this node to this node. That will be a wavelength. You see, wavelengths can be measured as the distance between 2 alternate nodes. That would be a good definition of wavelength. The distance between 2 alternate nodes. That's a node, that's a node, that's a node. Just measure that distance. Now, I get that distance Exactly 55 centimeter. 55 centimeter is how many meters? 0.55. So this time the wavelength is 0.55 meter. So I have the frequency 45.6 hertz. The wavelength is 0. Remember that's not 6. 0.55 meter. Calculate the wave speed. Okay, let's now go and look at the next mode. That is the fifth harmonic. Increase the frequency until we get the fifth mode. Alright, look at this. I lost it. Alright. No, I didn't get the fifth mode. Where is the fifth mode? There we are. Give me a second, I will have to reset it. Alright, here I have the beautiful fifth mode of vibration. You have how many full loops? Well, I said I got a beautiful one and it sort of failed me. Is that right? Alright, try it again. Well, I need to hold on to this because it is tilting off. Well, this is the fifth mode of vibration. Now, what is the wavelength is 0.4 meter. Let me cut that out. It is 0.4. Okay, I need to reset it again. Now, let's do one more. Let's get the sixth mode of vibration, or the sixth harmonic. Look at this. 1, 2, 3, 4, 5, 6. Aren't there 6 loops in there? Don't they look beautiful? There you are. And now the frequency is 75. Now you write it down on your own. I'm not writing it down. Frequency is 75. And the wavelength is, you can measure the distance between any two alternate nodes, and I'm going to measure the distance between this node and this node. That will be a full wave. Alright, let me measure that. And that distance is 36 centimeter. I'm not writing, you need to write that on your own. Well, the frequency is 75 hertz. The wavelength is 36 centimeter. You need to write it in meters and calculate the wave speed. Okay. So, we measured the frequency and wavelength of each of the harmonics, and I want you to complete this table. You see, the last values I did not write. I hope you have those values. And complete this table and